You know, for most of human history, the night sky was just this beautiful, unchanging mystery, a canvas of tiny lights. And then, in what's really just a blink of an eye, cosmically speaking, our entire view of the universe just exploded. We're about to take a walk through that incredible story of discovery. And that's really the big question we're tackling here. How in the world did we go from just spotting a few wandering planets with our naked eyes to literally hearing the sound of black holes smashing into each other across the universe? It's a journey that starts with a simple piece of glass and ends with us detecting ripples in the very fabric of reality. It's an absolutely wild story of genius that has completely rewritten our place in the cosmos.
So, where does this all start? Well, it begins with one revolutionary invention. The telescope didn't just make things look bigger, it completely shattered our old ideas about the heavens and our little spot in it.
So, the first telescopes, the ones Galileo used, they had this really annoying flaw. The lenses would bend the light, but not perfectly, which created these blurry, rainbow-colored halos around everything. It's a problem called chromatic aberration. But then Isaac Newton comes along and asks this brilliant question: why bend the light through glass at all? His idea was to reflect it with mirrors instead. And just like that, boom, this simple change in design completely fixed the color distortion, giving us way sharper, clearer views of the stars. It was a total game changer.
Okay, so seeing things clearly, that was just step one. The next great leap forward was figuring out what the stars are actually made of. And it turns out the answer was hiding in the starlight itself all along.
And the key to this was a technique called stellar spectroscopy. The idea is honestly just brilliant. When you take the light from a star and split it into a rainbow, a spectrum, you can basically read its chemical secrets. All of a sudden, we could figure out the ingredients of objects that are millions and millions of light years away. So a scientist named Joseph Fraunhofer is looking at the sun's spectrum, and he notices something odd. It wasn't a perfect, smooth rainbow. There were these mysterious dark lines cutting through it. He had no idea at the time, but he'd stumbled upon something huge. These lines act as a unique fingerprint for every single chemical element. By matching these spectral fingerprints to elements we knew here on Earth, we could finally tell what distant stars were made of, things like hydrogen and helium. But then, an astronomer named Cecilia Payne made a discovery that turned everything on its head. For years, everyone just assumed a star's color was about what it was made of. Payne proved it was actually all about its temperature. A blue star isn't full of some blue stuff, it's just ridiculously hot. That one insight completely changed our understanding of stars. All right, so for the longest time, we were pretty sure our Milky Way galaxy, well, that was it. That was the whole universe. A big, beautiful, but kind of lonely island of stars. The next wave of discoveries would just blow that idea to smithereens and show us a cosmos that was bigger and weirder than anyone ever dreamed. And this story unfolds over decades. It starts back in 1845, when astronomers see these fuzzy, spirally things they call nebulae, but they have no clue what they are. Fast forward to 1923, and Edwin Hubble proves that one of them, Andromeda, isn't a cloud in our galaxy. It's a whole other galaxy, millions of light years away. And then, just a few years later, he drops an even bigger bombshell. Almost all of these other galaxies are flying away from us. The universe wasn't just sitting there, it was expanding. So, while astronomers are literally expanding the known universe before our eyes, one physicist is back on Earth, completely rewriting the fundamental laws that run the whole show. Of course, I'm talking about Albert Einstein. His theories of relativity changed everything we thought we knew about space, time, and gravity. You know, for hundreds of years, everyone just went with Newton's idea of gravity, right? This invisible force pulling things. Einstein comes along and says, nope, that's not it at all. He imagined space-time as a kind of flexible fabric, and massive things like planets and stars don't pull on other things, they just create a big dip in the fabric. And other objects, they're just rolling along the curves. So what we feel as gravity is actually just the geometry of space-time itself. Mind-bending, right? And of course, there's his other little hit single, E equals mc squared. It's the most famous equation in the world, and what it means is just profound. It says that mass and energy are really just two different sides of the same coin. An object's mass is basically a measure of its own incredibly concentrated energy. This is the very principle that makes the stars shine. Okay, so for almost 100 years, some of Einstein's craziest ideas were just that, theories on a chalkboard. But in this century, our technology finally caught up. We finally built tools sensitive enough to not just see the universe, but for the first time, to actually hear it. And then, 2015, it actually happened. Scientists detected gravitational waves, literal ripples in space-time that were created when two black holes smashed together over 1 billion years ago. It was this incredible confirmation of Einstein's theory, and it gave us a brand new way to observe the universe. We could finally hear the cosmos. And if hearing a black hole mashup wasn't mind-blowing enough, just 4 years later, we actually saw one. The Event Horizon Telescope, which is really a network of telescopes all over the world working together to create one giant Earth-sized eye, it captured the very first direct picture of a black hole's silhouette. Something that was pure theory became a real thing we could look at. Just amazing. And believe me, this journey is far from over. Right now, one of our own creations, the Voyager 1 probe, has left our solar system and is flying through the space between the stars. We found and confirmed over 5,000 planets orbiting other suns, which completely changes the hunt for life elsewhere. And our best explanation for how it all started, the Big Bang Theory, gives us this incredible scientific origin story for the universe we see today. So when you think about it, we've gone from a simple glass lens to a telescope the size of our own planet. And every single new tool we build has revealed a universe that is bigger, stranger, and more wonderful than we ever predicted. And it just leaves you with this one awesome question. What are we going to find next?